My name is Matthew Nelson. I am a first year's master's student here at UNL. I am studying agronomy and horticulture with a specialization in weed science as my degree program. And I started here in June, and at the end of May I'll be moving back to North Platte. We do research through the West Central Research and Extension Center is kind of my research location. Our lab studies herbicide applications, and being weed science, most people assume it's studying how herbicides affect weeds and how to control weeds, but we actually study the process of getting herbicides to the target, which is a complex science that involves a lot of physics and fluid dynamics and properties like that. But the main thing that I do in my research is I'm looking at a specific herbicide and looking at the consequences of what happens when you lose herbicide during your application in the form of drift. So herbicide drift is simply just your herbicide kind of leaving during or after your application. So moving off target due to wind or due to your spray droplets being too small. There's about a dozen different parameters that kind of affect herbicide drift. But my research is done both in a wind tunnel, which we have in North Platte, and then using a field sprayer out in the field, actually applying this herbicide into soybeans and then seeing how far off target it moves. And then I'm trying to figure out why it moves off target, looking at droplet size specifically, which plays a big role in how far herbicide drifts off target. Talking about why nozzle size and type and then droplet size matters comes down to a couple different things. So farmers have a wide variety of nozzles they can use, different manufacturers, different sizes, different types. And the type of nozzle and the size, we call it the orifice size, but basically the hole that the herbicide comes out of can determine the actual droplet size. And the droplet size is important because there are thresholds where a droplet smaller than size X will be prone to move off target. So in our research, it's normally a droplet around 200 microns, which practically, or I guess for a practical term, is about the diameter of a human hair, somewhere in that droplet size, so very small. Normally you can't see them unless there's a bunch of them kind of in a cloud and it's almost a fog at that point. So in herbicide application, we're hoping to avoid droplets that are that small. And the way I describe it to people is whenever you see somebody out spraying, if you can see a kind of a cloud hanging behind the sprayer as he's going through the field, those droplets are hanging up in the air because they're small droplets and it takes longer for them to reach the surface of the plants you're spraying. So the longer they sit in the air, the more wind can come up and blow those particles off target. So herbicide drift normally has impacts to sensitive vegetation, whether it's your neighbor's crops or somebody's vegetable fields or even your grandma's garden, something like that. And this new herbicide that my research is on is a 2,4-D herbicide called Enlist Duo. And 2,4-D is an old herbicide, but it's famous for drifting off target, and then once it does, it damages crops very, extremely, I guess you could say, even at very small amounts of herbicide like you would see from herbicide drift, whether it's tomatoes or your neighbor's soybeans or anything from grapes to basically any fruit crop. This herbicide will damage it. So understanding the drift of it is important, as this product's supposed to hit the market this summer, if not this summer, within the next year. And it'll be of great benefit to farmers because it's an effective product and it's a good herbicide. I would say the favorite part of my research has been learning more about sprayer technology, especially using a wind tunnel, something that I had never really imagined before, especially to be used for agriculture research. A lot of times you hear about wind tunnels and aerodynamics or testing building materials, but we use ours to basically measure the size of droplets as they come out of a nozzle. We actually use a laser, which is kind of cool, get to play with lasers. And we can push wind through a wind tunnel at like 15 miles an hour to see how far those droplets move once you spray them out of the nozzle. And for me, that's just been interesting because it was something I knew nothing about. Growing up on a farm and studying agronomy, I knew plenty about weeds and I knew some about herbicides, but I didn't really understand how complicated the process of spraying is, between what you spray and what nozzle you use and what pressure you use. Even what speed you drive the sprayer at has an impact on your herbicide application. So for me, I knew very little about that, and it's been really cool to learn tons about it, and I still have a lot more left to go, I guess.